Ich habe heute einen echten Techie eingeladen, den Dominic Williams. Er ist so halb in Silicon Valley und halb in der Schweiz angesiedelt. Dort hat er vor 5 Jahren eine Stiftung gegründet namens DFINITY und hat seitdem an einem Internet-Computer gearbeitet. Bevor ich jetzt ewig lang über dieses Produkt ausschweife, denn es ist tatsächlich sehr komplex, kann ich nur sagen, dass es dem Internet ermöglicht, Dienste und Softwares anzubieten, nativ zu hosten eigentlich, so wie es im Internet der 90er Jahre originär mal möglich war. Das ist ziemlich abgefahren, denn das würde auch heißen, dass kleinere und mittlere Unternehmen eben unabhängig von Cloud-Dienstleistern wie Amazon Web Services und Google Cloud Geschäftsmodelle entwickeln könnten und eben macht den Internetcomputer zu so einer kleinen europäischen Blockchain-Hoffnung. Das Interview mit Dominic ist auf Englisch, denn ich finde das Projekt sehr spannend und ja, er kann leider kein Deutsch. Deswegen bis gleich. Hi, Dominic. Nice to meet you.
You too. Hi.
Yeah, just to start with the first question, what's your opinion on the current Bitcoin rally? Do you check the Bitcoin price at the moment every day?
You know, I don't check it because it's a great way of distracting yourself. I think, you know, look, in the short term, you know, crypto markets tend to be quite random. But, you know, what the markets are looking to confirm right now is whether there's a continued long-term uptrend. And it's certainly looking positive for Bitcoin.
Yeah. I mean, you seem to be involved in the blockchain scene for quite some years. And in all your interviews, you seem also really fascinated by the underlying science. So I was wondering, what is it actually that fascinates you about it?
Well, you know, I sort of got involved working on the internals of blockchains and trying to find ways of speeding them up and making them more scalable and helping them do new things at the end of 2013. And I've been working on it full time ever since. So, you know, many years invested in that area. And before I got into working on blockchain full time, you know, I'd been working for many years with distributed systems, and even, you know, as far back as 1999, I've been working with cryptography. So in many ways, it was just a natural evolution for me. You know, I'm what's known as an engineering entrepreneur. So, you know, I'm very interested in engineering and computer science theory, but I'm also an entrepreneur. And crypto is this field of dreams. If you're an engineering entrepreneur, I think.
Yeah, it's and is it also from there where you got the inspiration for the internet computer from?
Well, you know, there was quite a path to where we are now. At the end of 2013, I was looking at how I could create a cryptocurrency for games. And the reason was I'd created a massively multiplayer online game for kids that had grown to some millions of users. And, you know, I'd created a lot of the infrastructure behind that myself. And that was certainly found its way into my work in crypto. But anyway, in 2013, I thought, well, look, you know, wouldn't it be great if there could be a cryptocurrency that people could use to move value between games? So the idea was, you know, you'd sell virtual goods in one game, take the cryptocurrency and use it to buy virtual goods in another game.
You were so early on with tokenization, basically.
Yeah, it was very early. And so, you know, clearly, you know, traditional proof of work blockchains wouldn't work for that purpose. And so I started looking at some early proof of stake esque chains. There was one called NXT. And I started digging into it. And, you know, I couldn't see how some things were secure. And so I got on the forums and I noticed, for example, with this NXT blockchain that, you know, the hash of the block was being used to select the next block forger, as they called it, the next block producer. And I said, well, why can't you just select why can't the current block producer just select the transactions so that the hash, selects another one of their nodes? And no one really answered me. And, over time, I came to realize that, the technology was pretty nascent, and a lot of work was going to be needed. It was nascent in a number of respects. It wasn't necessarily secure. I mean, Bitcoin's secure, but a lot of these new ways of doing things weren't secure, and they weren't performant and so on. So I spent all of 2014 just researching a particular branch of distributed computing and trying to apply it to the blockchain space. Worked in that full-time research through 2014. Early 2015, saw that there was a new way of doing things, and I've been involved with the folks at Ethereum, and I was very enamored with this idea of a world computer. And I realized that the way Ethereum was approaching the problem could never create a world computer, right? That could support everybody's software logic and data. And so, I sort of began working on that, and that led to where we are.
Perhaps you could explain in the simplest way possible what the internet computer is.
Today, the internet's created by a protocol called IP, which combines lots and lots of private networks to create a single global public network that's very robust and decentralized. And it really is, we take it for granted today, but the internet really is a miracle of protocol, results from a miracle of protocol engineering. Like, right now, I think you're in Berlin, I'm here in Palo Alto. The video data is flowing across numerous private networks. Yet the software involved on our respective devices only needs to know the IP address of the other software, the internet address of the computer running the other software and the port that it's listening on. That's incredible if you think about it. I mean, the software only needs to know this number representing the address of the other computer and the port that software is listening on, because there's an awful lot of complexity involved in moving this video data back and forwards. And the internet really is an extraordinary agreement. I would guess, our data is probably, traveling across, up to 15 private networks, possibly more. So, okay, the internet computer is created by a protocol called ICP, Internet Computer Protocol. IP is Internet Protocol. It's created by a protocol called ICP that runs over the top of the internet and weaves together compute capacity from special node machines run by data centers to create the internet computer, which is also unstoppable. It's designed to withstand a nuclear strike, tamper-proof. Of course, it's essentially a blockchain system, and the software you build on top of it is built using smart contracts. So it's tamper-proof. You don't need a firewall to protect it or anything like that, and supports autonomy and tokenization and other key features that you need to rebuild the internet ecosystem. So
it means that you basically you can build everything on the internet itself, but how is it related to the big tech? Like, why is one of the targets you do have is the idea that little guys should be less dependent on big tech? So why is this an issue?
Well, I mean, there are lots of reasons why I think society shouldn't depend on huge big tech monopolies for its infrastructure. There are lots of problems with it, and these problems, are technical, economic, and philosophical. So let's look at the technical problems. Just a few days ago, Amazon Web Services had an outage, and a huge chunk of the internet went down, right? And that's because, today people are building internet services and enterprise systems inside these hyperscale data centers run by big tech monopolies. Now, personally speaking, as somebody interested in creating robust computing infrastructures like the internet, which can withstand a nuclear strike, I think that's a very bad design. And as was illustrated a few days ago, but much worse can happen. I mean, somebody could fly an airplane into one of those buildings. Yeah. Climate change could send a tornado through one. A solar flare could knock it out with an electromagnetic pulse. And so it's a very fragile architecture. So I don't like it technically at all. Secondly, with respect to economics, it's actually the nature of today's technology stack that's driving the increasing monopolization of the internet. And that's a subtle point I think that's often missed. And the problem there is that, if you end up consolidating the internet to say, 4 or 5 companies, right? In the end, it'll be impossible for anybody to create new ventures. And that essentially means that there'll be no innovation. And we can see this kind of thing already. I mean, look, Gmail came out how many years ago? Well over a decade, right?
Yeah.
And,
also, Facebook hasn't changed much ever since it was created.
That's right. Once you've established your monopolistic position, you just defend it. You don't innovate.
Yeah.
So this is really very, very bad for the world. And, I just think philosophically, economics aside, look, the markets aren't going to develop and these services aren't going to develop if innovation is impossible. And that means new value won't be created. So it's bad for the economy. But I also think, the concentration of power in the hands of a few big tech mega monopolies is not desirable either. So, all in all, I think the whole thing needs to be replaced.
Cool. So yeah, and I was wondering, so if we sort of decentralize it, and but how we structure it in a way that we can actually scale it up to the point that it's just as useful as the internet today, because actually, yeah, as I said at the beginning, it seems to be quite seamless. And yeah, how do you do it as good or better?
Well, there's two parts to this question, right? One is, technically, how do you enable a blockchain network like the internet computer to support hyperscale internet services using smart contracts? And then the other part is, how do you enable people to build dApps, decentralized applications that have competitive advantages over big tech's monopolies? Because it's no good just saying to the average consumer, oh, hey, man, this is running using smart contracts on a more open platform. Like there's only a very small section of the consumer audience that cares about that. You have to enable dApp developers to gain competitive advantages over big tech monopolies. Otherwise, it just won't go anywhere. So with respect to the first question, all I can tell you is that, blockchain's come a very long way since, the early days of Satoshi, when, these systems could be put together by a small number of individuals. The internet computer depends on a lot of advanced computer science and a lot of advanced cryptography. The reason that the DFINITY Foundation has built out such a large R&D organization is that delivering this involves a lot of R&D. We made the joke once in 2017 that, we were building a NASA for decentralization, but we were serious. And, I think it's fair to say the DFINITY Foundation, for example, has the most elite team of cryptographers within any organization in the world. And that's including places like Google and, Facebook and IBM and so on.
Did you actually convince some people from Google and Amazon to move to your association?
Oh, sure. So, look, our VP of research is a guy called Jan Kameny. She's a very famous cryptographer, ACM decorated cryptographer, responsible for a huge number of, seminal works and inventions in the field. And he was sort of leading crypto research at IBM. And, he left IBM a few years ago and became VP of research at DFINITY. And a lot of IBM's senior cryptographers followed him. But, we've got plenty of other, very senior, well-known cryptographers in the team too.
Yeah, it's definitely very complex, but I could see that you've been working on a lot of different projects, and there's always a lot of speaking around things, but it's also nice to actually know where the project is currently at, because I think that's what most people are very curious of. And so, yeah, maybe if you look at your vision and your mission, maybe, so where do you believe the project is today?
Well, it's come a long way. I think it makes me laugh because, in blockchain, there's this paradigm where people just take a pre-existing, blockchain code base, tweak it a bit, and then launch a new blockchain, right? And then monetize their tokens. First of all, there's Bitcoin, and then you got this kind of army of altcoins that really were just, Bitcoin with a few tweaks to the block time and things like that. Then we had Ethereum, and now we have a whole load of, Ethereum copycats who promise to speed up Ethereum, but, really just reusing the old technology and plugging in a new consensus system and make it proof of stake or something like that. And there's always this incredible rush to market, and there's not really much R&D involved. People are just trying to monetize tokens. The DFINITY Foundation is not for profit. We're building the internet computer, and we're in this for the long term. This is a project that will continue for many decades. And so just necessarily, it's completely new. We couldn't reuse anything. It's had to be built from the ground up and involves a lot of novel cryptography, distributed computing, virtual machine, technology, and so on. So, necessarily it took a long time. Ironically, many people out there in the blockchain community look at this and say, this DFINITY Foundation, it's a scam or something like that, because we haven't launched a token. And people deduce from the fact that we haven't launched a token and put out a kind of crappy altcoin that they're
hungry for investment, probably.
Well, yeah, and so it's mystifying to me, but that's often what happens. Anyway, however, I am very pleased to say that after many years of development, with a huge amount of R&D, that we're now reaching the point where this network is actually finally, launching. So the network actually enters the first stage of decentralization this December, which essentially means that control of the network is handed over to a thing called the network nervous system. So the internet computer actually has a sort of algorithmic governance system that resides within the protocol called the network nervous system. So the network itself doesn't depend on a not-for-profit organization like the internet depends on ICANN. It's actually, fully adaptive and self-governing, and it can upgrade itself and so on. So in December, the network is undergoing the first stage of decentralization.
So now, this month.
Sometime this December, it'll stop being reset. So things that are uploaded to it won't be, up onto the network, won't be deleted. The network nervous system is configured initially with a limited number of neurons that are being given out to sort of data centers and people related to data centers and the DFINITY Foundation, the ICA. So that's just phase one of decentralization, but it's a big deal. It's this event, the last of 5 public milestones on the way to this network sort of spinning out. It's called Mercury. There's a further step that will take place when various technical gates have been passed. I'm guessing February, March next year. Which is called Genesis, when people who have previously acquired tokens through other means will be able to extract them to neurons, and if they want to, they can dissolve the neurons and get the tokens. With respect to the sort of blockchain economy, that's when people will see ICP tokens appear on exchanges. ICP tokens used to be called DFN, if anyone out there is worrying.
Yeah.
But that's going to happen February, March. So finally,
how do the people earn the token by then? How does it work? By using the internet computer, or how do you earn those?
Sure. So it's a more complex setup than you see on a traditional blockchain. There are actually 2 kinds of token. There's a governance token called ICP, which you can use to participate in the governance of the network by locking them inside these voting neurons inside the network nervous system. Mm-hmm. And these things can also be transformed into cycles, and cycles are the approximate equivalent of gas on Ethereum, but the internet computer has a reverse gas model. So essentially you charge up your canisters, which are like contracts, with cycles, and then they burn through it when they perform computations.
Oh, wow.
Yeah, so the reverse gas model essentially means that users of systems and services built on the internet computer don't need to have tokens themselves. And that's been one of the key pain points, friction points for people building on platforms this far, because for example, if you interact with an Ethereum dApp, you need to have Ether tokens, and you need to have a cryptocurrency wallet configured in your browser, and you need to be sort of configuring gas payments in every transaction. So that goes away. For an end user, they don't even. If you wanted to, you could make a system on the internet, a service on the internet computer that looked like it was running on Amazon Web Services. Mm-hmm. And also, of course, the internet computer directly serves, can directly serve user experiences to users. So, content comes straight off the internet computer into the browser, and you get end-to-end security. But with respect to the sort of economic cycle, the internet computer protocol rewards data centers with governance tokens. It basically uses a system that's a kind of evolution of proof of work, where the protocol can detect the standardized hardware the standardized node machines that data centers are running, and it rewards them in terms of constant value for each one. But rather than rewarding hashing, it's rewarding the contribution of compute capacity. So in a way, it's a kind of form of proof of work. So the protocol rewards data centers for running these node machines, these standardized node machines, in approximately constant terms, right? The data centers obviously need to raise money to pay for their buildings and bandwidth and electricity and all these machines and so on. And
yeah, it was a bit similar.
They can sell them to users who transform them into cycles to pay for computation.
Wow, that sounds that sounds very, very complex, definitely. But what you did this year, I think it was after 5 years of working on different projects, you presented in January this year at the World Economic Forum in Davos the first DFINITY-based application. It was called LinkedUp, and it's a decentralized open source alternative to LinkedIn. And I found it very interesting because the service is neither controlled by a centralized provider like LinkedIn, nor does it rely on services from big tech players like Amazon and Microsoft that we were talking about them before. It runs, as you said, directly on the internet. But I was wondering, so does it have all the features that LinkedIn has, and what advantages does it actually bring? And maybe you could a bit elaborate on that.
So actually, LinkedUp was the first kind of sample app. So, it's not a service that we're going to support, but we want to make sure that early next year, people that want to build open internet services have, can start from sample dApps that show them how to do it. So actually, we switched from LinkedUp to a thing called CanCan, which is a TikTok clone. And we felt that, creating a TikTok, an open internet service that provided TikTok functionality was more challenging and more demonstrative of the capabilities of what's possible. And because, a social media service like TikTok that deals with user video has to be able to handle an awful amount of incoming user data. And, I think one of the things we've been trying to do is to reverse people's perception of blockchain. So traditionally, people have talked about blockchain just not being able to scale, right? And there's all these limitations and it's just too difficult. we see things very differently. We see blockchain as a scaling solution. So, building something like TikTok on the internet computer using essentially a new form of smart contracts is actually simpler than building it using legacy IT. So, we're going to be promoting blockchain as a scaling solution that makes it easier to build hyperscale internet services. So that's why we moved from LinkedIn to this TikTok clone called CanCan. And of course, the other piece of that is, the internet computer blockchain will stream video directly back to users. So, back in the Sodium event this summer, we demonstrated uploading, I forget, some gigabytes of data very quickly onto the internet computer testnet.
Yeah, so, but the thing is, I mean, it's great if people actually create some of these applications on the protocol, but I mean, there are, let's say, for example, the TikTok on the blockchain or something. How should those attract users? I mean, if you already have a TikTok profile, why should I use a TikTok on the blockchain?
Sure.
I mean, what's the incentive for them to, for incentive for developers earning tokens is one thing, but on the other side, like users, how do we convince people to switch to open alternative TikTok? Because they don't care if it's blockchain. They just want to use.
Precisely. Well, yeah. So this is exactly the right question to ask. Because in the past, the blockchain industry hasn't really had an answer to that. As a professional serial entrepreneur, I know how difficult it is to get traction. Okay. And oftentimes, if you want to take on an incumbent, a monopolistic incumbent, the only way you can succeed is if you introduce completely new, novel, compelling advantages into your service that the incumbent can't also offer, right? So let's think about those and how that might be achieved by, how you might create an open internet service with those kind of advantages. So, first of all, we've seen that when you convert your internet service into an open internet service, you can raise money by selling the governance tokens. But that's not enough. You've still got to work out how to beat out, you've got money to develop your service, but you've still got to work out how to beat out the monopolistic big tech incumbent. Okay, so you need special advantages. Let's think about what those might be. So first of all, let's just take some example services, 3 example services. Let's think how we build an open alternative to Google Photos. Let's think how we build an open alternative to Uber. And then let's think about CanCan. And this will provide any entrepreneurs out there listening with a kind of roadmap, right? This is for any crypto entrepreneurs. Open Google Photos, right? So Google Photos, it's following the standard big tech monopolistic playbook. They told everybody that they would never lock our photos in. A year ago, they stopped allowing you to sync your photos to your hard drive. And now, of course, they've announced that they're going to introduce some pretty punitive pricing for storing your photos. So you can't get them out, but you've got to pay, otherwise your photos will disappear, right? And I think it's true that you can click into each photo and right-click download, but if you've got thousands of photos, obviously that's impractical. So, okay, so now we can see this unfolding. How are we going to beat Google Photos? Right. First of all, let's use DeFi to give people an alternative way of paying to host their photographs. So one of the problems with Google Photos and iCloud too is that if you get ill or die, your credit card expires and all the photographs disappear. Mm-hmm. And this is a really big problem. A lot of people are finding that a relative is ill or dies and the credit card expires and they lose all their family photos. How are we going to get past that? Okay, so with open photos, you can use DeFi to give users a feature where they make a deposit once, and in return for that deposit, they get, say, an eternal 1 terabyte of photo storage. That's pretty cool, right? Make one payment, and then you've got a terabyte of storage forever, for eternity. How does that work? where you take that deposit, convert it into a token like ICP, and then put it into a margin lending scheme like Compound, and you use the interest from the margin lending scheme to pay for the ongoing storage costs.
Do you think this will attract people who actually have no idea of crypto?
Well, you don't know, but you know, you don't need to know about crypto to see why that's a valuable feature. I mean, if you're a consumer, sure, when you see the Google Photos, and
if I'm a consumer and I go and I try to convert anything to Compound, for example, that's definitely.
No, but you don't. No, but you don't do that. You don't do that.
I don't do that.
Open Photos does this, right?
Okay.
The user just makes a payment once, and in exchange for that payment, they get a terabyte of photo storage that lasts forever, right? They don't have to keep on paying every month.
Yes.
You don't do that. You don't go to Compound and get involved in DeFi. You're just a user. You just make a payment, and in exchange for that payment, you get a terabyte of photo storage that lasts forever, and you never have to make another payment. And that means that if you get ill or you're in hospital and your credit card, or you're in jail and your credit card expires, when you come to, your photos won't have disappeared, right? And so that's a great feature that Google Photos and iCloud will find very difficult to match.
Yeah.
Secondly, security. Just a few weeks ago, white hat hackers were invited to attack Apple, and they got inside, and they found that they could see everybody's iCloud photographs. Right? And they could do some other things too, like they found they could get into the systems that push software updates to MacBooks and iPhones, but let's ignore that for the moment. They could see everybody's iCloud photographs. As far as I know, something similar hasn't happened at Google, but it's certainly true that anybody working at Google in the relevant department can look at your photographs. With open photos, you can design it so that people's photographs are stored in a way that no hacker can access them.
Yeah.
And even malicious systems administrators at the data centers cannot see those photographs, because if they open up the machines, the machines that have replicas of the photographs stored in open photos, all they'll see is encrypted random bytes. Thirdly, open photos is able to share functionality and data with other services if you give it permission in a non-revocable way, using something called non-revocable APIs. And this means that independent teams can extend the functionality of open photos. So now, as a result of that, users of open photos will see that there is an ever expanding array, for example, of photo filters that they can apply, and more exciting, varied ways of, cool new ways they can use their photographs. So these are all things that, big tech monopolies can't do. Big tech monopoly doesn't have blockchain DeFi. Big tech monopolies aren't blockchains. They're not tamper-proof. So, your photographs can get hacked, and people working in big tech organizations can see your photographs. So they can't offer true privacy to users. And big tech has in the past offered APIs, but anyone who builds on top of those APIs comes a terrible cropper, because if you compete with them, they take your access away.
It's also very risky in case they change the regulation. The whole business model can just be destroyed.
Today, collaboration has become impossible. If you build on top of any big tech API, very likely out of the blue, you're going to find your service stops working. And we've seen this kind of thing happen over and over again. The reason we actually chose LinkedIn was because it was one of the most egregious examples of this. It used to share professional profiles with other services.
Yeah, they stopped doing it.
And it stopped doing it, and thousands of startups were just wrecked overnight by this.
Yes. Yeah, that's actually, this sounds like a big vision. Like it's very, very impressive. But I also think there's a lot of expectations now on DFINITY, and I think some people, they assume, it's going to be bigger than Ethereum, and Ethereum is already quite big, and you got a lot of funding I think it was the DFINITY was worth 2 billion, what I found online, which is definitely quite a lot of money. But did you ever feel like the expectation is a bit too high on your project, or did you ever have the feeling of, oh, maybe that's a bit, I'm gonna lose hope. This is too complicated. This is such a big vision, you know?
I mean, you know, the financial dimension was never the objective. Okay, so that doesn't worry us at all. Look, I think we see a sort of we see the internet computer as a very necessary third major innovation in blockchain. Bitcoin was obviously the first stateful decentralized network, and it provided us with what I believe is digital gold. And I think increasingly, you know, people outside the crypto sphere are seeing Bitcoin as digital gold, and we're seeing, you know, cash flows from that would have gone into gold and going into Bitcoin and things like that. Ethereum was the world's first highly programmable cryptocurrency, and I think it's played that role very well. You know, people decry things like the ICO boom and things like that, but, you know, history is going to be very kind to Ethereum. It's going to look back and it's going to say, wow, you know, they showed that it's possible to enable people to raise money from the internet rather than, you know, in a decentralized manner through these ICOs, rather than directly from, you know, VCs and so on. They showed that it's possible to create all kinds of DeFi from smart contracts, and you know, even things that are listed as Ethereum's biggest failures, I think in hindsight will be viewed very kindly. Like, you know, the DAO. I mean, you know, the decentralized autonomous organization that was actually called the DAO. Yeah, sure, it went wrong and it got hacked. But yeah, look, this was the world's first decentralized venture capital fund. So, you know, that's done very well too. The purpose of the internet computer is to, you know, enable something on an even, you know, grander scale in some sense. It's to create this thing that we describe as a blockchain computer, you know, unbounded blockchain computer. And we want this. We essentially want blockchain to replace legacy IT. You know, we want people to build on a blockchain using an advanced evolution of smart contracts. And in doing so, we want people to completely reinvent society's infrastructure. We don't want, you know, society depending on these fragile, monopolistic services run by big tech from hyperscale data centers. Mm-hmm. You know, we want to make sure that, you know, the internet provides a degree of security, transparency. It's unstoppable. We want to enable all of the world's talent to participate in this system. And we don't want to see organizations hijacking user data. We don't like the monopolistic playbook. You know, Slack just got acquired by Salesforce for, what is it, like $27, $28 billion. In today's, you know, hyper-monopolistic world, you know,
everything get consolidated. There's so high consolidation.
Yeah, it's consolidation, right? I mean, even if you're a public company, you know, worth that much money, you know, you're an acquisition target for big tech, and in the end, you know, all of society's compute infrastructure is going to be consolidated into the control of a handful of companies, and this is bad in so many ways. It's not good. You know, as we covered, you know, it's not good for the economy. It kills innovation. It's very insecure and fragile. It's not good for society, you know, for a whole bunch of reasons. It takes our freedoms away. So, you know, the internet computer is this third major innovation of blockchain that aims to solve this and actually, you know, turn the traditional perception of it's difficult to scale blockchain on its head by showing the world, no, it's the opposite now, right? Blockchain is a scaling solution. You can build a hyperscale internet service on the internet computer blockchain more easily than you can build it on big tech's legacy IT stack.
Yeah. Yeah, that sounds very promising, and I'm wondering. So you spoke about next year. It's gonna go live. Is it right? Or are we able to use CanCan next year on the Internet Computer?
Well, look, yeah. So first of all, you can already download a canister SDK. So canisters are a kind of an evolution of smart contracts. It's really fun if you're a developer because it uses something called orthogonal persistence. A canister basically contains WebAssembly bytecode in the format of a software actor that you've compiled down from a language like Motoko, which is a new language we're developing, or Rust, or several other languages that people are bringing to the SDK. That bytecode inside the canister is bundled with the memory pages it runs in. So on the Internet Computer, there's no concept of files or databases. Your data persists and lives inside of your variables, objects, collections, and data types. So you can download alpha copy, beta copy of the SDK right now and start playing around with this kind of stuff. And there's a lot of amazing advantages. The Internet Computer reimagined software. But separately to that, the Internet Computer Network itself is undergoing the first phase of decentralization this December, which means that it will not, anything you upload to that network will no longer be reset. The big launch, I think, or the event that the public will consider launch is Token Genesis, which will happen February, March next year. By then, we will have completed CanCan pretty much end to end, so people can use it as a template to just start building their own hyperscale internet services. And yeah, many other things are happening. All of the online content's being revamped. One of the things we're struggling with, ironically, is we haven't developed all of this in the open. A bunch of our stuff is open source, but we've got to we've got to take all of the code, put it into the public domain. It's also very different to a traditional blockchain. Traditional blockchains like to say, here's our white paper, and it talks about some kind of consensus protocol or something like that. You can think about the Internet Computer Project as hundreds of white papers and thousands of pages of technical documentation. So we're trying to work out how to get this into the public domain in a digestible way. And once we've done all of that, we've got the code out, a sufficient amount of the technical documentation out there. CanCan's complete end-to-end at the moment. It just upload. You can use it to upload video data, stream video data, and search that video data. But obviously, an end-to-end internet service can, needs a lot of other things like authentication. So we're going to show people how to do that and so on. So that's coming in the new year. So it's a good time to get involved, learn more about it. And one of the ways of doing that is just download the DFINITY, the SDK that DFINITY creates, which at the moment supports Motoko. Hey, Mike, is Rust in the SDK? Has been released, right? Yes, yeah. So at the moment it supports Motoko and Rust, which are two great languages, and start playing around and exploring things like orthogonal persistence. Yeah.
Cool. Thank you for the interview.
Thanks, Tom. Yeah.